In our two panels today, we're going to focus one on technology and one on content. And please keep in mind that they are not separate as we're talking about the two today, sensing and tracking for 3D narratives. They come together in the user's experience. But because we want to emphasize some of the research that's taking place at Stanford, some of the new ideas that are emerging here, we've separated them for the purposes of the panel. And you're going to have an opportunity to learn about research activities, development, innovation that's happening in 4 different areas of Stanford. I'm going to ask each of the panelists to introduce themselves and to say a little bit about what they do here and what some of the new activities are that they're pursuing. To get us going, first we have Nitish, and then we have Nick, then we have Jay, then we have Vincent. And so let's start here with you, Nitish. Tell us what you're doing.
I work in the Stanford Computational Imaging Lab, and we work on opto-computational display technology. In particular, what I tend to work on is a lot of the perceptual conflicts in VR that our previous speaker went into in one of the questions. That 20-minute limit, for example, is partly due to something called the divergence accommodation conflict, where your eyes are focused to a different distance from where your eyes are converging to. And also recently I've been working on the vestibular conflict, which is motion sickness, but in reverse, basically.
So if you were to summarize the improvements that you hope will happen from the technology that you're developing, what are you trying to create?
So the idea would be basically to try to extend that 20-minute time limit to something a lot longer so that you wouldn't have to be constrained to these rare experiences. And for social VR especially, you don't want to be constrained to 20-minute sessions with your friends. So you'd be getting rid of symptoms like eye strain, motion sickness, and even like nausea and anything else that pops up for those conflicts.
And so can you just in very simple words tell us what you're doing that help the nausea and the motion sickness to go away?
Sorry. Okay, so with the eye strain, that's more on the accommodation version side, and what we're working on there is either moving displays or changing focal lengths of the lenses in the head-mounted displays so that you reduce that conflict between where the image is displayed and where your eyes focus, assuming that the images are. And for the vestibular conflict, it's a lot harder. We're not quite sure where to go with it yet. It's more of an investigative, like what causes these problems more than others, and are there ways to maybe disable one of those senses to get rid of the conflict by basically having your brain ignore it?
So getting each eye and the brain to work together.
Not quite. Basically to get your senses that report to your brain to report either the same thing or one of them to just not report so the other one basically provides a driving influence.
Great. Super. Nick, yeah.
Yeah, so I'm Nick Haber. I'm a postdoctoral fellow in the Wall Lab at Stanford here. So Wall Lab essentially does autism research. And I'm working on a project for a therapeutic tool for kids with autism. Many kids with autism struggle to recognize social cues, to put it in brief. And there's sort of a standard cognitive behavioral therapy, which is essentially flashcards of happy, sad, angry, surprised, and so on, where they memorize these social cues and get normalized to them. And we develop a tool using currently Google Glass, so it's not necessarily the only form factor, where we're providing real-time social cues by using automatic facial expression recognition. So I think a couple interesting things about this product overall is one that it's essentially trying to do augmented and mobile technology for a sort of ubiquitous therapy and diagnostics. And at the same time, it's using interactive machine learning and active learning technologies to, I would say, like close the semantic feedback loop. That is, like make devices get better by asking questions of the user.
So you're using both sensing and tracking to improve the experience. for the person who's wearing the glass, as well as for the people in their context and the people who are helping them.
Exactly.
In a therapeutic way.
Exactly. The child with autism is wearing the device. Their parent actually interacts with it heavily as well. The current form factors is that it's the glass paired with the phone. The parent can interact through the phone. The child has the glass, and they can work together.
To help the wearer understand the social cues faster so they can respond in a more socially intelligent way.
Exactly.
Yeah, great. Jay.
Hi folks, I'm Jay Borenstein. I teach in the computer science department, including a course on content creation in virtual reality, which has to do, frankly, with leveraging some of the development environments that are common out there. Unreal Engine is the one that I have the most comfort with, but Unity is the most ubiquitous, those being the two. And in particular, I have an interest in leveraging virtual reality on behalf of education. And one of the areas that I think is a really exciting frontier that VR enables in a way that wasn't possible before is around social emotional learning. And for those of you that aren't familiar with that, there is a field of emotional intelligence and the research shows there that kids who are exposed to best practices in this arena as part of their K through 12 education have better outcomes across the board. They have better self-esteem, better healthy relationships, better academic outcomes. So all outcomes that we would want, and yet it's underrepresented in the K through 12 space. And part of that is it's sort of hard to simulate emotional circumstances and be able to react to them. But VR, for the first time, makes some of that possible. So that's something that I'm exploring.
In creating educational or learning experiences that have a social emotional context, what are the sensing and tracking technologies that you're teaching people to employ?
Well, so I think there are a lot of interesting things there. So biofeedback is one area that gives you a lot of clues. So if you correlate heart rate and sweat rate and things like this, that's along with what is happening in the simulation at the time. Over time, you develop an ability to predict how people are feeling in different circumstances, and then your experience can react in a useful way according to that.
Great, great. Vincent, please.
Hi, I'm Vincent. Now I'm working from the ITRI. Yeah, it's from Taiwan. It's a semi-government organization for the research. And now I'm a visiting scholar collaboration with the Stanford Prevention Research Center with Professor A.B. King's lab. And we have the one system for the virtual coach system, and we have the video to show for explain to everyone. Yeah.
Okay, let's run the video if you would.
It's our virtual coach system. Yeah.
Can you describe how it works, Vincent?
Yes.
Okay.
Sure. Irregular lifestyle will lead to the fatty liver disease and like the diabetes and hypertension or hepatitis. Yeah. So we developed the system for the up to the 70% people doesn't reach the effective exercise intensity. So we developed the system that the people can conveniently do the exercise in their house or their home. Yeah. So we developed the motion-based system for the rehabilitation. Yeah, we use we can fetch the activity and we integration a wearable device to detect the physicality and we analysis how many calories in your do the exercise. So we can get the personal and customized better program for the next time you do the exercise. So we use an in-depth camera to fetch your action occurrence, and we can calculate your action similarity percentage. So through the virtual coach system, we can do the real time to detect and thread analysis, and also we can do the instruction. Yeah. So this system, we have many scenarios, like for the rehabilitation with the hospital, and we also do the fitness in their home or in the gym. Yeah. So we already collaboration with the heart failure center with integration the heartbeat watch, and we also integration like the clinical guideline. We can help the heart patient to improve their compliance. Yeah, and we also do the field trial. It's a large scale in our community. Yeah. After 3 months, we can improve the balance rate up to 146%. Yeah. So extend to the international worldwide. We also collaboration with the Singapore University Hospital. We focus the patient with the born condition. Yeah. So this now is a collaboration with IBM, yeah, Singapore. So we still think to the many opportunity to on demand on a different field, yeah. So it's our motion-based virtual coach system, yeah. Yeah.
Great, thank you. Thank you very much. So we've talked about different types of sensing, and just, to capture that again, the types of sensing and tracking that you're using for feedback in your respective virtual environments are, for you, Vincent, you're capturing biological.
Yeah. We capture like the in-depth camera. We can fetch the skeleton, and we can get the skeleton similarity. Is depends on the doctor design the training program, and we also detect the heartbeat, because the heartbeat is like the elder and younger, they have a different age, so we calculate the body age. So we need to reach your heartbeat, so we can reach the effective exercise intensity.
Okay, and this is on the individual level.
Yeah.
Okay, and Jay, the kinds of feedback that you're using are?
Biofeedback, as well as movement within a scene. Those are the primary things. We're also exploring sort of introspective sensors that look at facial gestures and things like this.
On the individual?
On the individual, yeah,
Okay.
at the individual level.
And Nick?
So we do mostly affect recognition on the face, and feedback we use is essentially just, so this is augmented reality. It's sight and sound on a heads-up display and earpiece. We've actually also played a bit with more thorough mixed reality, such as Microsoft HoloLens, where you get localized feedback in 3D in front of you.
Mm-hmm. Okay. And you're focused on the individual.
Right. So a lot of the feedback, I'd say, is in eye tracking and ideally vergence tracking, which is, again, how your eyes converge. But we're also looking at things like where your eyes are focused to individually, but not using feedback on that, just to measure it. And head tracking, possibly also posture tracking. I think that's
Great.
about it.
So most focused on the individual, but from a variety of different types of sensing and tracking technologies. One interesting thing that I know your lab is working on, Nick, and I wonder if you'd talk about it a little bit, is being able to detect contextual signals where there may be, in a family setting, more than one individual that the person wearing the glass is interacting with, and how that complexity is being handled.
Yeah. So that's actually, I mean, something that's super interesting from my standpoint, right? Where this is getting into the field of affective computing. You want to be able to tell, read the affect in a room, be able to tell who's happy, who's bored, who's anxious, and so on. And the way that we actually recognize affect is far more complex and time dependent and based on very particular little social cues than what is the standard of affective computing. If you look at the research today, which is essentially a bunch of psych students making faces, and they're paid a few dollars to do that. What we want to do is actually get more realistic data and be able to semantically annotate that in an efficient manner. That's a huge challenge. If you actually think about teaching your computer how all the little bits of your affect recognition come together, or at least giving it all those bits and allowing it to piece together the pattern, that's a huge challenge. And so we're working on various kind of efficient learning techniques by which one can explore realistic data and do that.
You want to say a little bit about the Delta technique you're developing?
The active learning. Right?
Yeah.
Yeah. So it's so. I mean, like the idea is, and this broadly falls into what's called active learning. In standard machine learning, there's this. You gather data and you shove it into a machine and it learns from it. It learns a pattern, and then there's a nice model that comes out, hopefully. That's sort of short-sighted if the task of gathering data is expensive. So if you can imagine a machine instead having a conversation with you where it asks, like, it has some baseline idea of what's going on, but then asks you questions. Say, like, I was not sure about this point, what was happening? I was not sure about this point, what was happening? Could you give me some information? Could you label that data for me? And that's what we're playing with to be able to make these sorts of things better. And I think that's basically the only way up to be able to deal with more complex types of data and get systems that recognize a more realistic scenario and can give feedback on it.
And Nitish, you're using some of the feedback that comes from individual looking at the way that each eye works and the way that they verge. Are you using some of those techniques as well to be able to kind of, for an individual, I mean, ultimately be able to put my corrective lenses inside my headset?
Yeah, actually, we built a couple of prototypes that do that. We basically, measuring the prescription, you could do that in the headset itself if you have optics that can, change the focal distance of where that display is being placed in the virtual world, and just have them move it back and forth until they see that it's sharp in one range and not sharp in another. And that would actually, to a crude approximation, give you their prescription, assuming, of course, they don't have astigmatism and other things. But we can actually also use that again in reverse and take the eye tracking and say, oh, they're looking at content that's far away or nearby, and then we can virtually move that scene to where they're looking at. And of course, we can correct that distance based on the prescription again.
That is so awesome. I think one of the other interesting developments, Vincent, maybe you can comment on this, is the helping people who are standing by to facilitate the rehab process and to help individuals, whether they're correcting the way that they're doing the exercises or speed or how hard they're working. Can you say a little bit about the support system that you're thinking of behind the vCoach?
Yes. Before we developed the virtual coach system is just for the cardiac patient. So cardiac patient, they can do after the surgery, they can do the more high levels exercise. So we need to focus to control their exercise level. And now we use we let the doctor to on the remote side to guide their how to do the exercise and the real time through the video and the voice. And after we already have a new version, use the ontology. We use ontology to reason we follow the ACSM. ACSM is an American College of the Sports Medicine. It's like the exercise prescription. Yeah, we can do the ontology, then we can automatically to feedback to the patient. So it's our next step. Yeah.
So you've got the medical professional in the loop,
Yeah.
as it were.
Yeah.
Right?
So we call this a clinical decision support system.
Great. Well, I'm going to ask another question of all of the panelists, and then I'll open up to questions from all of us here, because I think these are incredible resources and new frontiers that they're pioneering. But when you are working on technology, what about the content in VR do you think about?
Well, okay, so when I look at it, there's a lot of, since I'm working on mostly perceptual conflicts at this point, I'm looking at how far away is the content from the user relative to where the virtual image of the display is being placed, how fast is stuff moving, and how fast is the person being shown that they're moving when they're actually not, and to what extent does this affect their perception or lack of perception of motion and distance.
Mm-hmm. Great. How about you, Nick?
I mean, I guess I mostly think about you take a look at a sort of the real world experience, how to semantically, give it good semantic values so that it's you can teach both people and machines, and sort of they teach each other.
Yeah, I think I focus on the emotional impact and how that maps to emotions that someone's feeling in the real world. It's a tough thing to measure, but I think it's one of the exciting opportunities.
I know that you are very familiar with the software that's used to create the content. And are there some specialized software that respond or that correlate to emotional state?
Well, I think one of the we've talked a little bit about data and sort of machine learning. The larger the data set that you have, you plug that in, you get sort of more accurate models at the end. We're in this really interesting time where, particularly in some of the work that's being described here, data is not that easy to come by. But I think if you fast forward a few years, then when we have far more people who are able to experience VR in high fidelity, the access to data is going to be more analogous to the kind of data that we get from the web or from mobile these days, which allows us to really understand accurately how people are experiencing different things. So I think that is very exciting, and that will lend itself to APIs and other sort of structures that are made available to content creators that can actually capture some of the emotional state for people accurately, and also account for variance in the way people experience the same thing differently, which is one of the really tricky things right now.
So as you're talking, I'm imagining a kind of pull down in the editing suite of VR content that would say, this route for excited, this route for engaged and distracted.
Yeah, I mean, I guess you could. That's to be determined. That's kind of a reactive way, or you could you could be trying to solve for eliciting different feelings in different circumstances, which is what we're trying to do. We're trying to, for example, for a teenager, create a situation that maybe is one that induces stress for them, and then give them some tools for resolving that stress.
Mm-hmm. I see. So the tools that you're talking about help to create the content rather than make the choices of which content to take next.
Correct.
Got it. Vincent, what do you think about for content when you're developing the tools?
For us, for the V-Coach content, I think that it depends which disease do you want to solve. So, like we already have many use cases like a stroke patient or a cardiac patient or a bone condition patient. It depends your disease. So we try to looking for the different type exercise video in front of the patient. So we're now working with the ABK's lab. We do the list. What's the content is for the folks group. So like before we have use the Tai-Chi video, we combine the pressure sensor in the force, and we can calculate their center of gravity. Yeah. Mm-hmm. So it depends disease for us, and now we already extend to do the exercise in their home, in your life. So the content for us is very important. Yeah. So we still looking to try what's the content for the different group is for them is helpful. Yeah.
It's very exciting. Maybe you would like to respond in terms of how you are seeing the user in the real world in the applications that you're developing, Nick.
Yeah, so I mean, you know, we certainly do like augmented and mixed reality. So we don't cut people off from the experience. And I think so. We're currently using Google Glass to do feedback with this, and the idea with Google Glass is actually to give minimally obtrusive feedback, so that they're actually essentially able to have a conversation without having very much disturbance at all. So be mostly in the real world and very little in augmented. We're also playing, as I said, with something more mixed reality, more full mixed reality experiences like with HoloLens. So they're again in the real world, but have then a very full heads-up display, which can actually project holograms into the real world and give localized feedback to the real world, overlaying it on that. So that's where I think there's a really interesting thing in this sort of mixed reality, where you can actually, you know, be able to interact with the real world and the virtual world at the same time. And that'll be, I mean, the technology needs to really get there. Right now we have this like heavy thing that sits on your head, and it's a nice, it's impressive machine. It's really fun to play with. You're not going to put it on kids' heads. You're not going to wear it for very long yourself. And there's a good deal of inaccuracy with respect to how the real world and the virtual world match up with it. But as that thing matures, I think that there's all sorts of new ways we can explore feedback, and I think that'll be really exciting.
Others of you want to comment on that?
Actually, for us, we just in our idea is just help for the user. Actually, the in-depth camera is can gather 3D point, but we just to fetch something we want, then we can help the patient. So for the rehabilitation, we just need to in-depth in-depth RGB point. We can feedback to the patient. Yeah.
Mm-hmm. This may be a question for Vincent and Nick, but Jeremy made reference to the need to know how long the impact lasts and how it works with an individual. Are either of you beginning to explore this question when somebody has the AR, the experience, how long the effect lasts with them?
Okay. Yeah. So I mean, we're specifically doing this in the context of therapy, and we do very much care about, you know, first off, I mean, how long they are going to be, how long is a normal usage period for this sort of thing? How long will they be engaged with it? And if they are learning things from it, how long after that lasts? And so we run sort of a design trial where we put that on them and got some very good feedback. You know, they can work it into their lives several times a week for 2 to 3 months before sort of normalizing behavior and novelty falls off. But then, you know, the question is, of course, what do they take with it after them? And that's what we're currently launching a randomized controlled trial where we'll hopefully have measurements on that. If can we get some sort of persistent result on their lives as a result of the dosage?
Yeah, interesting. Other questions? Yes, please.
I was wondering, in the course of your research, for all of you, what kinds of surprisingly counterintuitive things did you come across?
Surprises.
I had an interesting one for working with kids with autism. Working on feedback mechanisms with it, we did quite a bit of design where there's a question with autism where there are all sorts of sensory sensitivities. They don't like certain noises. They don't like certain smells. They won't like wear things in their ears, for instance. You think that you might want to sort of minimize the level of feedback that you get, or be very sensitive to that. But we found, I think, quite universally that sort of as they get normalized to a device, they like it. They like more and more feedback, and they like more and more gamification of the system for engagement.
Interesting. Nitish, surprises for you?
I'm not sure if there's many in the way of surprises for us, especially since we're working more on the display technology side, and a lot of the optical features of the human system have been studied for decades, really, but just not in a VR context, but rather in a real-world context. We're finding that a lot of this stuff carries over, but I think the one thing that sticks out as a surprise would be that when we tested preferences for people in different display modes, we seemed to find that they preferred a sharp, clear image over a fused image, and that was based on other measurements of how well they could fuse and how sharp things appeared. And that was strange, but it could just be due to time limits of experiments. And
Jay?
I would say I've been surprised by how some people experience the same emotion very differently. So one person, when they're scared, might have their heart rate go down, and somebody else might have their heart rate beat really quickly. So and there's lots of other data that's like that. So it is surprising how different we are as people in the way that we experience the same emotion. When we would interview that person after something, they'd say, yeah, I was very happy, or I was very scared, and yet the data that was collected around that experience was quite variable.
So that presents challenges for the content developer, I guess.
It does. It requires a baseline, essentially. The hope initially was that there would be some consistencies across all human beings that we could look for, and I think that probably still is the case. But where we are right now is each individual basically has to set up their experience by getting a baseline for what their emotional state is.
Interesting, very. Vincent, how about you? Surprises?
For our system, actually, the patient usually is do the rehabilitation in the hospital. But because we have the virtual coach system into the community in elders' home, they can use the virtual coach to rehabilitation in their house. So they don't need to spend many time to go to the hospital. So they were surprised, oh, they don't need to meet doctor every time. So they get a surprise for this, and also like the interesting video, they can get a more surprise in our different content. Yeah.
Okay. Let me throw in a question here while others are thinking, and I think that we've talked about a number of different types of tracking, and imagine all of that information going in to inform the content as it unfolds to the user. What's your sense of how many feeds of tracking will be able to accommodate in terms of creating narratives or content? Now, Vincent, you're dealing with several now, with both the physiological, how a person is standing, with their cardio, with their body movement. Do you think we'll be able to expand to infinity tracking information that would come in to inform the content, or will we settle on 3, or is 1, we're going to develop applications for content that have just 1? What do you think? Start down here with you.
For us, now we already developed the virtual coach system, already have many versions. So we have still have the next step, like before we trace the heartbeat is with the heartbeat watch. Now we try to use another thing, like the user camera. We can detect your heartbeat through your breath or your RGB image. So maybe we can use this new idea for the combine the new content into our virtual coach system.
Jay, what's your sense of the complexity of tracking information we can use for narratives?
I think it's going to wind up being quite complex. I think generally I'm a computer scientist. I'm confident in one thing that computers do well is process a lot of information very, very quickly. So I think it's really the barrier there is not the computational power, it's our understanding of what to program the computer to do. And as I said, I think we'll get smarter as more and more people are in virtual reality and we have more data to understand how they're experiencing it. I think we'll rapidly accelerate. It'll be hundreds of inputs for sure.
Mm-hmm. Good, thanks. Nick, how about you?
Yeah, I think in general, you know, as with any sort of where you're doing a predictive task, the more modalities, the better. They're complex and potentially noisy. So I mean, I think we can get certainly a long way with sight and sound, but adding on, augmenting that, I think generally speaking, when you're dealing with perceiving the real world, these senses are all quite important. So it's processing all these things and finding a way to marry them is a huge challenge, but does tend to produce better outcomes.
Mm-hmm. Oh, Nitish.
I'm in general agreement with everyone else. I think that more pieces of sensory information are always, it's going to allow us to do more things with virtual reality, and they may not all be quite as important, but as we get towards full immersion, those tiny little differences start to be more and more important pieces.
It's interesting that in some forms of media, we've had a very strong movement toward personalization, whether it's on your screen or on your phone. And you have all spoken about some element of personalization that may come to VR. Where is that personalization going to be? Is it going to be in the hardware? Is it going to be in the software? What do you think?
I think there is some potential for personalization in hardware, but software, I think, is going to be much bigger levels of variability between people, just because it's a lot easier to do, or it's a lot easier to make software that's different per person than it is to make massive amounts of hardware that is imperceptibly different for each person. Mm-hmm. But again, each person's sensory, how they interpret their senses is slightly different, and so there does probably need to be some amount of hardware personalization as well.
Jay, you spoke about the differences among people.
Yeah, well, I just kind of supply chain economics, I think the hardware will end up being fairly standard with a little bit of ability to custom, but yeah, the software, I think, will increasingly be things like, you know, we're taking baselines of people's emotional states for some of the research that we're doing, but I think that, you know, that'll be extended across a lot of different things, so that yeah, people experience different things in VR in the way that works for them.
Do you have opportunities to get together with others to share what you're doing?
I mean, I think, yeah. I don't talk with these guys, but I'd like to.
Yeah.
I'll invite you again.
All right. No, it's yeah. I think yeah, certainly that's very important and sort of a challenging task, I think, as people get sort of solid into research programs. And I would say that I guess I've not done too much with the VR community, because what we do from a virtual reality standpoint is quite is fairly simple, aside from that, as we use it as an augmenting tool. That we do, I think sort of we see a nice marriage in you know, a combination of medicine, computer science, neuroscience, and psychology. And as we see sort of these fields converge around these sorts of interesting things, that's where I see a lot of talking happening these days on these sorts of topics.
But I would just say I think it's a great point, and I think actually one of the cool things about the VR community right now is it's still relatively nascent, and there are a lot of thought leaders who still are available to interact with people who are new to the field in a way that isn't possible once it's really broadly adopted. So it is kind of this, there is an opportunity for thought exchange across all sorts of different work that's going on in the field. And I think it actually is pretty good. Like it's like relative to a lot of things, I think the idea exchange and people kind of all being on the same page and trying to move the field forward, I think that's a real thing right now that does exist in the VR community.
I think from a standpoint at Stanford, we are exceptional because we have, I guess what you would call bench strength in the expertise areas that go into virtual reality, from education to communication, electrical engineering, computer science, physics, music, law. People in all of those areas are very interested in virtual reality and sharing information. Yeah. You're next.
But I don't know if kids are going to have Google Cardboard, or they all need to get an Oculus, or where are they going to get that, and what's the best medium? And do I target one or all of them?
Getting it out there. What do you think?
Yeah, I can
Jay?
speak to that, I'd say. So first of all, I would say developing for VR is actually more approachable than you think. Most of my students here find it easier to develop at least a prototype and a value-added experience in VR than they do as a mobile application, for example. And that's because the development environments are really robust. They give you a lot of the 3D modeling that you need. They abstract that. Now, it's very true that to polish it and get it all the way to the point where it was a production-ready piece, that takes a lot more different players. Design needs to be a first-class citizen. There's a lot of complications with it. But to get it to the point where it's adding value is actually not nearly as hard as people think. So that's the first piece. The second piece is these development environments, they do a lot of the lifting for you in terms of compiling it down to something that's going to run on Gear, for example, or on the Rift, or in a mobile environment. So that part's not as hard either. It's if you really want to do something that's on the frontier of what's done before, you're going to have to write your own C++ code that you're plugging into things that the engines give you for free. Then that certainly does get complicated. But there's a lot you can do without having to do that. In terms of which platform should I develop it for? Well, it depends what you're going for. If it's a super high-end experience, then right now that's a tethered experience to a workstation. Although at OC3, Oculus's latest event, they talked about having an untethered product that's in the pipeline, so that's coming. But there's sort of this high-end, the HTC product, the Oculus product, and then there's the Gear product and the Google product. And if you want to reach the most people, then right now the right way to do that is through Cardboard and Gear. But you'll certainly see, I mean, the hardware cost is going to come down for everybody. So it's only going to get easier.
Back here.
And I'm just curious if you are involved in or are aware of anyone who is looking at the factors impacting adoption of virtual reality, and how virtual reality seems to be positioned as a lead-in for augmented reality to sit in between VR and person-to-person contact.
That's a good question to ask for this panel. We can bring it up for the content panel as well. But any ideas on that? Of the variety of media of which VR and AR are part, how are they positioning themselves relative to each other in the user's experience?
I certainly come from a camp where we do tend to think that AR is something that will that'll be big and be an important part of how we interact, and perhaps will lead to some ability to decently get something closer to person-to-person interaction. I don't know actually if I had people who study trying to bridge that gap, but that's sort of it. Yeah, we definitely see. I think basically, as you said, VR to AR to person-to-person, and somehow we'd want that guy to be in the middle.
I think maybe taking it back to some of the comments that Jeremy made earlier, that some of the advantages of VR are particular to putting someone into an experience where they would otherwise be in danger, or if it were expensive or rare, or if it be counterproductive for the experience to be real. And that's not necessarily trying to replace the interpersonal interaction. There was a hand over here. Yes, sir.
So I'm curious about the neuroscience of that and how VR might start to merge with our understanding of, we talked about augmented reality as well. And that's really, if I can see a hologram in my living room versus see it in my goggles, how does that impact our definition of being a sensate being?
Yeah, that's a great question.
Yeah, that's a deep one. So there's an interesting research study about American teenagers right now, that apparently American teenagers prefer to interact with their friends via Snapchat or some two-dimensional environment. They prefer that to being together with them, which I think I'm just becoming an old curmudgeon, but that feels strange to me. So let's fast forward. Let's say that a few years from now, their preferred medium of interacting with their friends is in a virtual environment where they feel like they're together. They feel like they're experiencing different things together. Is that a progression in terms of, are we more human at that point, or is that a regression? Is that less human than where we are now? I don't have the answer to that, but there are a lot of philosophical things, pieces like this, and sort of understandings of ourselves that society is going to have to confront that are out there.
We do have some experiments, some research underway here at Stanford that is capturing some of the brain signals while people are involved in immersive experiences. And those are underway at this point in time, not ready for reporting, but maybe at one of our future conferences we'll have some results from that. And they are exciting results. Let me ask a question of each of you, and thinking about the technology innovations that you've been working on, but the challenges that you've also defined, either for your personal work or for the field going forward. If there were 3 current challenges that you could solve that would change how fast you could go into the future, what would those be?
Should I start?
Yeah, start please.
I'm not sure if there are 3 that I can name off the top of my head, but at the very least, I think in terms of adapting displays to people in terms of both distance of the virtual image and also to their prescriptions, one limitation currently would be that with focused tunable lenses that change their focal length, they tend to be rather on the small side, so they'll cut out a lot of that field of view that presumably leads to immersion. And then on the other hand, moving the display instead, moving parts break. So that's always an issue. A second problem I'd say is just display technology in general. We've gotten so much better in the last several years, but there's still certain things that are being worked on that are needed to make displays basically faster, higher resolution, and less prone to basically blurring due to motion perceptually. They're not actually blurring anything. Yeah.
Yeah, great. Thank you. Nick, how about you? What could be moved out of your way as challenges that would let you go faster?
Well, yeah, I don't know if I want to move that because I want to work on it. But
okay, that's good too.
But I think, a couple of things that we moved out of my way. It'd be great to see, I think, as wearables and augmented reality starts to succeed a little bit more, we'll have things that are that have better battery life. They don't heat up and scare people. They don't they're less obtrusive. Sort of just better form factor. You'll see happen in I think the fairly near term. The second would be, as sort of alluded to earlier with that question on the limitations of a large display. The actual marriage of mixed reality with the real world and actually being able to overlay things in a real world in a really accurate way. That'll lead to some really interesting interactive experiences. And the third one, and then this is maybe what I work on, so I don't want to just disappear, but is machines that learn more like us, if they're able to ask questions of the world and ask questions of us, so that they can learn by themselves. This sort of efficiency in how we do machine learning and artificial intelligence will really change a lot about how we.
That's exciting. That's very exciting.
Yeah, I think I would say I would have 2. The first one is equitable access to hardware that's capable of delivering the experiences. Right now that's prohibitive. So if that could be removed, I think that would really be a game changer for VR and AR. And then the second piece, I think, is actually the perception that society at large has of the space. Right now we're in that stage where it's the average person's either unaware or somewhat skeptical or scared. And I think there's a long way to go before there's sort of comfort in broad adoption. And if that could be accelerated, I think that'd be a real boon to the field.
That's great. How about you, Vince?
For us, like our virtual core system, we have the exercise prescription. So we already have automation to matching your video type. So now we make the 40 or 50 video on the cloud. So we need automation to stream into the elder's home. So maybe this automation mechanism is we will use the machine learning technology to help we choose the right content to the right guy. Yeah.
Oh, great, great. Let me ask you all to kind of shift your perspective a little bit. And we've been talking about the technology from a technology standpoint, but I want you to now think of the content developers. And I'd like to know from each of you, as you are thinking about the content developers, the people who are creating narratives or stories or experiences from the tools that you're working on, what are 2 things that you would like for them to keep in mind about your technology as they're developing their narratives? Vincent, I'll start with you.
Like us, we need the patient, they are already sick, so they can accept to do the more thing in their sick process. So I think that our content developer needed to use more spend time to create a story that them can get interesting for the rehabilitation. Yeah.
Mm-hmm. Okay.
I think the key is just to take advantage of the medium. And Jeremy talked about it a little bit, that what we see right now, a lot of the top experiences in the Steam store or the Oculus store are either recreations of, or sort of like the evolution of games that already exist, or of sort of relaying experiences, real world experiences, and bringing them to your to this medium. But we can go way beyond that. And I think if we look back, like 5 years from now, we look back to where we are now, it'll be kind of like when TV was invented, and the first black and white TV shows were just basically radio shows of people sitting around talking. I think we'll feel that way about what people are doing with VR right now. We'll look back and we'll say, oh yeah, they were just basically taking what already existed and moving it over to this new medium. I would encourage content creators to think about how to take advantage of this immersive environment that can trigger emotional responses in a way that wasn't possible before, to do radically new things that weren't possible before.
Perhaps in slightly longer term, the adaptive learning to personalize systems to individual people, I think will lead to all sorts of new opportunities for content. And hopefully in the shorter term, I think we're going to see a certain ubiquitousness in mobile health with these sorts of tools. So going beyond, well beyond Fitbit telling you how many steps you've moved, to real diagnostic and potentially therapeutic.
Great. Nitish.
A lot of my work is on basically measuring limitations for content and trying to go beyond those limitations as caused by people's perceptual conflicts. And so ideally, we would find ways to remove those conflicts in VR caused by the basic fact that we're sitting still in one place and looking at one screen at one distance, and just give more freedom for content developers to develop experiences that don't mess with people on a nauseating level.
That's great. Well, thank you very much for sharing your experiences, your research, and your visions for the future with us. Join me in thanking the panel.